Sets of the real number system. Now, while dealing with the real number system, we're going to consider the following sets. 1. The set of natural numbers. 2. The set of integers. 3. The set of rational numbers. 4. The set of irrational numbers. And 5. The set of real numbers. So, let's consider the first one, the set of natural numbers. The set of natural numbers consists of all positive whole numbers. It is denoted by n, all positive whole numbers. These numbers are 1, 2, 3, 4, 5, 6 to infinity. So all of the numbers that fall within this set from 1 to infinity are all the natural numbers. Let's move forward. The set of integers. The set of integers consists of all positive and negative whole numbers, including 0. It is denoted by z. All positive and negative whole numbers. So, for minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3 to infinity. So all the numbers that fall within this set, they are integers. So numbers like minus 10 is an element of integer. Minus 100 is an element of integer. 5 is an element of integer. 7 is an element of integers. So these are for the integers. Minus negative whole numbers and positive whole numbers are all members of integers. Now let's move over to rational number. The set of rational numbers consists of those numbers which can be expressed as a fraction. So a number that can be expressed as a fraction is known as a rational numbers. It is denoted by Q. Rational numbers is denoted by Q. Now the best way to express the rational numbers is using the rule method. Q is equals to A over B. The rational number is equals to A over B, such that A and B are elements of integers and B is not equals to 0. So the rational numbers is actually a fraction, which is A over B, such that A and B are integers and B is not 0. So any number that can be expressed as a fraction is a rational numbers. Now, a good example of the rational numbers are the natural numbers. 1. The natural numbers are also rational numbers. Now, why do we say this? Now, let's list out some natural numbers. 5, 7, 10, 35. Now, all of these numbers which are natural can be expressed as a fraction. 5 can be expressed as 5 over 1. 5 over 1 is a fraction, therefore 5 is a rational number. Over 7. 7 is the same thing as 14 over 2. 14 over 2 is 7. 7 can be expressed as a fraction, and such it is a rational number. 10. 10 is the same thing as 100 over 10. 35 is 70 over 2. So since we can express all of this number as a fraction, therefore all the natural numbers are rational numbers. So from here we can say that the natural number is a subset of the rational numbers. Now if we are to let's move over to more examples on the rational numbers. We are dealing with the rational numbers. Another example of the rational numbers are the integers. All integers are also rational numbers. Now let's write an example of integers. Minus 5, minus 3, 4, 10. Now we can express all of these numbers as a fraction. 4 is the same thing as 8 over 2. 10 is the same thing as 70 over 7. So since we can express all of these numbers as a fraction, then all integers are rational numbers. So integers are subset of the rational numbers. So we have two examples so far. The natural numbers are rational numbers. Integers are also rational numbers. Now let's take another example. All fractions are rational numbers. Example 2, example 3, fraction. So all fractions, 5 over 6, 8 over 15, 7 over 23, 10 over 17, all of these fractions, they are rational numbers. And that is the definition. Rational numbers are numbers that can be expressed as a fraction. So obviously fractions are natural numbers. So let's take a fourth example. The fourth examples of numbers that are rational. These are numbers that have terminating or recurring decimal. We must take note that it is not all decimal numbers that are rational, but it is a decimal number that has a terminating or recurring decimal. When we talk about terminating decimal, we means numbers that has decimal points and whose digits after decimal point can be counted. Now these are lists of numbers with decimal points: 0.65, 3.412, 4.337, 5.87321. Now each of these numbers has decimal point. Now the first one here, it has two digits after decimal point. The decimal point terminates at 5. The second one have 3 digits after decimal point, which terminate at 2. 3 digits also, which terminate at 7. While this one, it has 5 digits after decimal point, which terminates at 1. So each of these decimal number has a terminating decimal, which also imply that they are all rational numbers. Now to make the picture clearer, I'll give you an example of a number that does not have terminating decimal. For us to do that, let's go over to my calculator. Now, a number that does not have a terminating decimal is the root of 3. Root 3. Now, root 3 is equals to 1.7320508050756887. Now, this decimal point did not end here. If we scroll, you see that the number continues. Okay, initially it at 77, and this is the 77. After 7, we have other numbers. Okay, this is 77 here. Then continue with 2, 935, 527, 444, 63, 34, 10, 58. If you keep on scrolling, you will scroll from now to infinity. The decimal point will not end. It keep on going. Now this number here shows you the number of digits after the decimal point. It's already 1175. If you keep on scrolling, you keep on going, you keep on going. So root of 3 does not have a terminating decimal. Number keep going. Let me scroll to 2000. We are at 2000 already, 2041. You scroll to infinity. So this is an example of a number that does not have a terminating decimal. And let's go back. But each of this number here, the decimal points terminate, which means that it is a terminating decimal number. Now, another thing we should observe, we can convert all of these numbers here to fraction. For example, 0.65 is the same thing as 65 over 100. 3.412 is the same thing as 3,412 over 1000. 4.337 is same thing as 4,337 over 1000. Why this digit here is same thing as 5,87321 over 1. Let me count the 0. This is 1, 2, 3, 4, 5. So 5 zeros. Good. Now we've expressed each of these numbers as fractions. I remembered the definition of rational numbers. A rational number is a number that can be expressed as a fraction. Now, since we can express each of these numbers as a fraction, then they are rational numbers. For a number with a decimal point that does not terminate, so we cannot express that number as a fraction. Hence, that number is not a rational number. Now, let's talk about the recurring decimal. The recurring decimals, these are numbers that does not terminate, decimal numbers that does not terminate, but it's just the same number that keep on reoccurring. And this set of numbers, they are rationals. For example, let's consider this number 8 over 3. Now 8 over 3, it has a recurring decimal, as you can see from the calculator. 8 divided 3. 8 over 3 is equals to 2.666666666. Now how many 6 do we have? The number of 6 did not terminate. It just keep on going to infinity. So a number like 8 over 3 is something as 2.6666 to infinity. And that good number is 5 over 3. If you divide it, it's 1.66666. You keep on going. So numbers that has recurring decimal, although they do not terminate, but still they are rational numbers, as you can see. So assuming it's number like 2.555555555 that does not terminate, this number become a rational number. So we must note that it's not all decimal numbers that are rational numbers. It's a number that has a terminating decimal, just like this first part, or a number that has a recurring decimal. The decimal number just keep on reoccurring, then they are rational numbers. But if a decimal number did not terminate or did not reoccur, then that decimal number is not a rational number. So now we'll move over to the next. Irrational numbers. The set of irrational numbers consists of those numbers which cannot be expressed as a fraction. It is denoted by I. It's just the opposite of the rational numbers. The irrational numbers cannot be expressed as a fraction. Now, if there's any number that is not a rational number, that number is an irrational number. Example of numbers that are irrational, they are pi, root 2, root 7, root 11. Now, the root of a number that is not a perfect square is a rational number. But don't make the mistake of you putting root 4, because root 4 is a perfect square, which is 2, and 2 is a rational number. Or root 9, 3 is a rational number. But in the case of root 2 is not a perfect square. So therefore, the value for it will have a decimal number that does not terminate. And since the decimal number does not terminate, hence it is an irrational number. So just simply put, if a number cannot be expressed as a fraction, if a number is not a rational number, that number is an irrational number. Let's move now to the next set of numbers. And that number is called the real number. The set of real numbers denoted by arrow consists of all rational and irrational numbers. So real number is denoted by arrow, and it consists of all the rational numbers the rational numbers and the irrational numbers. So if we add the rational numbers and the irrational numbers together, we have the real number. Remember, the rational numbers are numbers that can be expressed as a fraction, while the irrational numbers are numbers that cannot be expressed as a fraction. So the real numbers like minus 30 is an element of the real number. Number like 3.42. Now 3.42, this is a rational number. It's an element of the real number. Number like root 5. Root 5 is an irrational number. It's an element of the real number. So this is a set of the real number system. All the number we can think of, they are real numbers. So this is all for the real number system. If you want to know more about the real number system, you have any questions, you can ask me directly on WhatsApp. Meanwhile, do not forget to subscribe and share this video. Bye.